All right, I did not supposed to divide this into two videos. So point estimation and statistical interviews should be on the same video, but I divided. So anyways, we will have this one, the part two of our second part of this module. Right. So statistical intervals, these are a range of values that provide an estimate of where a population parameter is likely to be. For example, our population mean could be from this lower limit up to this upper limit. Okay. So we have limits, and then in between the limits is our interval. Okay. So statistical intervals are used to quantify the uncertainty or variability associated with estimating population parameters based on sample data. So, meaning if this is our interval, then there's a higher chance that we meet the target. For example, here, if we have if you can see this part, 68% within one standard deviation. So if this portion is our um, interval, then there's a higher chance that we meet this target, this estimated population mean. The higher chance that we are closer to that. Okay, that the estimate is somewhere very close to that population mean. Okay, or the actual value is very close to our estimated population mean, which is the center. But if you have a higher interval, meaning a larger or a wider gap between your lower limit and your upper limit, so there's a very small chance that there's a lower chance that uh, that the true value is equal to your estimated value. Okay, estimated parameter. And you'll see that more once we have our sample problems. Okay, so in statistics, the most common types of intervals include the confidence intervals, prediction intervals, and tolerance intervals. Okay, in the sample problems handout, we have some problem solving examples here, there. But for now, take note that our focus for this course is more on the confidence intervals. Okay, that's what we're going to use once we do our hypothesis testing. So, a confidence interval or the CI is a range of values within which we can be reasonably certain that the true population parameter lies. So, like what I said, within these limits, within this interval, okay, the area between the two limits, um, it should be or the more narrow it is, the higher chance that our estimation and the actual value will be the same. Okay, but if we have a wider interval, so higher difference between the lower limit and the upper limit, then there's a plenty of other possible values. So we have a lower chance that our population estimate will be equal to the true value. Okay, so it's like there's a higher chance that we miss. Okay, but lower CI will have a higher chance that we hit the target. All right, so that's confidence interval. We are more confident if we have a smaller interval. Okay, so one of the things that we use for describing our confidence of intervals is the margin of error or the MOE. So that's also the letter E that we used in Cochrane's sampling formula. So the MOE is the measure of the uncertainty or the range of values that is associated with a sample estimate. And mathematically, that is something that we add or subtract with the estimate. So I already mentioned we have the lower limit and the upper limit. So here we have this lower limit and upper limit. So the distance in between them is our confidence interval. Okay, and how do we get the lower limit and upper limit? First, we have our estimate and our margin of error. So we just subtract our MOE from the estimate to get the lower limit. So if the estimate is 75 and the MOE is 5, then the lower limit is 75 minus 5, which is 70. Okay? But if again, if the estimate is 75 and the MOE is 5, then the upper limit is 80. So all in all, our confidence interval is just the difference between the upper limit and the lower limit. So if the lower limit is 70 and the upper limit is 80, then therefore the confidence interval is 80 minus 70, and that is 10. Okay? And now that means our CI is based on the MOE. So a smaller MOE corresponds to a narrower confidence interval, indicating a more precise estimate of the population parameter. So meaning we have fewer options, meaning few a lower chance that we miss the target. Okay? That means we have a higher confidence. Okay? So we choose a narrow MOE only so that we can be more certain of our estimate. Okay? And there are many types of MOE, or many ways to compute for the MOE depending on what is given, what is known or unknown. Okay? For a population mean that has a known standard deviation, we use this formula. Okay? The z-score divided by square root of n. Um, if we have an unknown standard deviation, then we use the t-score divided by square root of n. And if we have the population proportion, we can solve for the MOE using this formula. Okay. By the way, this is for the given z-score critical value and the given sample size. Okay, where P is your population proportion. Okay, I believe that this is all for our statistical intervals.